Okay, please try to finish them at home. Please try to finish them at home, okay? And we'll start the next topic now. If you can look up. So, next we're going to have a look at something called a sequence. A word I'm sure some people know. So does anyone want to try and tell me what a sequence is?
A set of numbers that follow a certain order.
Almost. One word was wrong in that.
Numbers that follow an order.
No, just one word was wrong. Just one word. Sequence?
We give up numbers put in order.
Again, same problem as him. Something's wrong with that. Not quite that. No. Almost.
We give up.
Okay. A sequence is a list, not a set. A list, or if you want to use the word set, you would have to say ordered set.
Set in order.
Not the same thing as an ordered set. You know, grammar. Right, a list of usually numbers, although it doesn't have to be numbers, it just usually is numbers. A list of numbers that follow a given rule. And it'll be different for each situation. So here's our first example of a sequence, a very simple sequence. 1, 2, 3, 4, etc. So this sequence is just the list of numbers increased by 1 each time. Here's another one. 2, 4, 6, 8. What's next? 10 will be next. Right, let's see how good you are at spotting patterns. 2, 3, 5, 7, 11, 13, 17 would be next. What is the name of these numbers? Yeah, these ones will be prime numbers. These ones?
Even
not
numbers.
Optimus Prime. These ones?
Even numbers.
Even numbers. And these ones?
Natural numbers.
Natural numbers. Okay. Let's have some more difficult ones. -1, 1, 4, 8, 13, 19. Okay, think about that for a minute and then tell me the next number. What's the rule here?
Square.
Not squares? Yeah. Here you add 2, and here add 3, and here 4, 5, 6. So the next one you would add 7, making it 26. Okay. What about this one?
Squaring.
Yeah. Next one? 64.
Oh.
These are all sequences. I'll give you one more. Really hard one. What's next?
1, 1, 5.
No. You answered that way too quick, which means you didn't think about it long enough. Think about it for a minute. You have to give me the reason why as well.
It's
just on the tip of my tongue. It's
the term, the 2 before the 31. add them, and then add to them.
1 plus 1?
Plus 1.
1 plus 1 plus 1 plus 3?
1.
I'm thinking of ends, the term and then the rule that follows. But it's not working here.
Yeah? Does. The next one clearly is 8. Obviously, clearly. Yeah, now let me explain this one. Don't worry, this isn't something for the exam, but it's an interesting one. So this sequence, I suppose what I'm trying to say is, the rule could be anything. So here, what's the rule? Add 1. Here, what's the rule?
Times 2. Term times 2.
Well, not quite. Plus 2. Here, each number should be prime. Here, you add 2, and then increase what you add by 1. So add 2, 3, 4, 5, 6, 7. Here, you square the natural numbers, including 0. And now for the one I gave you, the rule is, you write down 1, and then you say what you see. Watch. 1. How many 1s do I have? 1. I have 1, 1. Now what do I have? I have 3 1s. Now what do I have? I have 4 1s and 1 3. Now what do I have? And so on and so on. You get the idea?
Can you put that in a formula?
No.
Yeah, that's why I cannot do it.
Yeah. But that was my point. It doesn't have to be a formula, it just has to be a rule. That's why I use the word rule and not formula. That's the point I was making with this one. Okay? So, my point here is it has to be a rule. It doesn't have to be a formula. Yeah? Okay. So, often though, it's more convenient to give sequences as formulas. So this is how we write the sequence as a formula. So UN represents the nth term. So for example, U1 represents the first term, U2 second, U3 third. And you can write these as formulas. Like for example, if I said 1 plus 2n, what would be the first term? Well, you make n1. So that would be 3. And then the next one you make n2, 5. And then the next one you could make 7. So actually, a lot of these you can write as a formula. Like this one here, un equals n. Here, un equals 2n. Yeah. No, because if it was n plus 1, you would get 2, 3, 4, 5 as your sequence. Yeah? So let's say something like, I'll give you a sequence here. Let's say 1 plus minus 1 power n. I want you to write down the first 3 terms, please. U1, U2, actually first 4 terms.
0, 1, 0, 1.
Yeah. Got this? So what's the first term?
0.
0. Next?
1.
1,
0.
0, and 1. Because the first one was 1 plus minus 1 power 1, which is 1 minus 1, which is 0. The next one was 1 plus minus 1 squared, which is 1 plus 1, which is 2, not 1. Whoever said 1. 2. The next one is 1 plus minus 1 cubed, which is 0. And then the next one is 1 plus minus 1 squared,
Not square, or 4.
So the same, 2. Yeah. Okay, can I scroll down? So, let me give you another formula. Let's say un equals 1 plus 1 over n. And this time I would like you to find u9, please. So, give me the answer as a fraction. Write it down. Did you write it down? So the 9th term here will be 1 plus 1 over 9, which is 10 over 9. That would be the 9th term. Okay. Now, there is another way to write down a sequence. So far, what you might call this method is a very direct method. You write the formula down directly. But there is another method called recursive. And let me show you what that means. That's when you give the formula like this. Let's use x instead of u this time. X n plus 1 equals 1 plus 1 over xn. And I tell you x1 is 1. So this is called a recursive method. It doesn't give you the formula directly. It only tells you what the next term is. Because if you think about it, if I have x1, x2, xn, what's the next term?
N plus 1.
xn plus 1. So this represents what comes next. And this is the term that you're at. So it's like you're here, and this formula can only tell you what's next. So for example, if you start at 1, then the next term would be 1 plus 1 over 1, which is 2. And the next term would be 1 plus 1 over 2. What's happening is, every time you get your answer, you put it back in here, and it gives you the next one. Then when you have your answer, you put it back in, and it gives you the next one. That's what it means to be recursive. It means you kind of have this loop.
Wait,
Yeah?
so you put the n value on the x, and then
I'll do another example, a little easier maybe. Can I scroll down a bit? Here's another example. Let's say un plus 1 equals 1 plus un. And I tell you to start at, let's say, 2. If I was to write this in words, what I would be saying is the next term is equal to 1 plus the term I'm at. That would be what it would be in sort of English, this formula. So for example, I start at 2. What's the next term? 1 plus the term. So that would be
1 plus 2.
Yeah, 3. What's the next term? 1 plus the term, so the next one would be 4. So the answer feeds back into the formula. This is what the word recursive means.
and what is the first one?
This has to be given to you. You have to be told where to start.
The un plus 1.
un plus 1 stands for next term.
So un plus 1 is 2. If it's the first one.
No, un is 2. Like here, look, I tell you to start with u1 equals 2. So that means this one here is 1 plus u1, which is 1 plus 2. If there's u1 here, what would this one be? If n is 1, u2. So that makes the next one. I know this might be a little tricky because it might be new for some people. Have you seen this before? You don't think so? You've seen it before? Yeah? You've seen this before? No, I didn't think so. Okay. I'll give you one to practice, and then I want to talk a bit more about this, but I'll give you one to try first. Can I scroll down? Are you okay? Yep. Yep. Nearly there. Nearly lunchtime. I know.
Now I'm full.
You had food?
Now I'm full.
What did you have?
I just had.
Again? Scroll down. Try this one. I tell you to start at, let's say, 0. No. Yes. Yes. And the formula is un plus 1 equals 2 plus 3n. Yeah, try this one. Give me the first 4 terms. Oh, what am I doing? Sorry, I'm being stupid. Forgive me. un.
The first 3?
First 4. Okay. u1 equals 0. What's u2? That's 2 plus 0, which is 2. The next term, u3, will be 2 plus 6, which is 8.
Yep.
No. Yes.
Yeah.
And then the last one, u4, is 2 plus 24, 26 then. There is a way to do this quickly on your calculator, and this should work for most calculators. Let me show you. So you can do this with me. Okay, so if you want to take out your calculator. So the first thing you do is you type in the first term, which in this case is 0, and then you press equals. Now the reason you're doing that is you're putting 0 into the answer button. So if you watch here, whenever I press answer, the number I get is 0. You see? So now 0 is saved in this key. Okay, so 0 equals. That's what you do first. Then let's clear the screen. So then you press AC. And then you type in 2 plus 3 answer. Now, what value is answer? 0. So what should I get here? 2. So I press equals and I get 2. But now, what value is answer? 2. So I have 2 plus 3 times 2, so I should get 8. Next, 26, 80, and so on. Now what's happening to this sequence? It keeps increasing and increasing and increasing. There's a name for this. You describe it as, does anyone know the name? No. Increase in sequence. No. Does anyone know the adjective?
Growing.
Growing sequence? No. Expanding sequence, no. Exponential sequence, no. Growing sequence, no.
That's enough of answer.
No. I'm convinced somebody knows it.
No, I mean, the calculator.
No. We'll keep going till we hit the error. Anybody?
Very close.
Anybody? The name of this sequence?
What's the first letter?
No. No. Don't. Nope. Okay. This is an example of a divergent sequence. So this word here means to increase to infinity.
And beyond.
Not beyond. As you can see, the calculator stopped at 10 to the 100. Please note this word, because in the exam they sometimes ask you, what type of sequence is this? This one is divergent, for example. Okay. Can I scroll down? I'll give you another sequence I want you to try. Can I scroll down? Try this one. Un equals 1. Un equals 1 minus 1 over un minus 1. Now,
You mean U1
Yeah.
is 1?
yes, u1 is 1, thank you. Now, I know it looks a little bit different, but if you think about it, it still means the same thing. If you're here at un minus 1, what's the next term?
1 minus 1 over 1.
No, I mean, like, what do you call it? U...
UN.
Please, make sure you're certain of the answer before you say it. Its next one is U...
N.
N, yeah. And then the next one is U...
N plus 1.
N plus 1. And the next one is UN plus 2. You get what I'm saying? Actually, you know what? I think I'll change this to a plus here. So, it still means this is the next term equals 1 plus 1 over the term. This one comes after this one, so it's still the next term. Okay, give me the first 5 terms here. The first 5.
You gave us U1.
Yeah. Okay, what's the next term? Well, let's use our calculator. So we store 1, and then we have 1 plus 1 over answer. So the next term is 2, and then 3 over 2.
Then 5 over 3.
5 over 3. And then 8 over 5.
Isn't it answer minus 1?
No. This is un minus 1, which means the previous term. It's not UN, it's not this, it's this. It's a different thing. Now, look here. Next term, 13 over 8, 21 over 13. Yeah. Guys, look up. Look up. Watch what happens here. What's happened? Stop. So this is not divergent. It's actually reaching a limit. What is the adjective for this? Does anyone know? Reaches a limit. It's trying to reach a limit. The opposite, the antonym of divergent. The opposite of divergent. Convergent. So we call this a convergent sequence.
The number becomes so small it doesn't make a difference.
Yeah.
We use this somewhere else. There's a formula, a different formula for this one.
Mm-hmm.
Or something else in a different lesson.
Perhaps. Maths is quite big. Okay, please write this one down. This is convergent. Okay, here's another one for you to try. Can I scroll down? Yes? UN plus 1 equals minus UN. U1 equals 1. Calculate the first 5 terms. Yeah, it starts off with 1, minus 1, 1, minus 1, 1. So, it's not really, you could call it divergent because it's not really convergent to anything. But there is another adjective we can use to describe this. Does anyone know? Say again? No, yeah, you're right. It is alternating, but a bit more general. Because there's another word that alternating only means for 2, whereas I'm thinking a word that could mean something like this: 1, 2, 3, 1, 2, 3, 1, 2, 3. Whereas alternating is just for 2. Another word for repetitive. Another word for this. A synonym of this. Yes. Possibly in the worksheet. Is it periodic? Is the name of something that repeats like this. Yeah.
Periodic sequence.
Yeah. Can I scroll down? Have a look at this sequence. UN plus 1 equals OR times UN. And I tell you U1 is, let's say, 1, for example. I want this sequence to be divergent. So what should I make the OR equal to make it divergent? Give me an example.
A fraction.
No. Like 2. Yes. Remember my previous request? Yes? Yes. So OR would need to be something like 2, 3, whatever. So for example, if OR was 2, what would happen with this sequence? You would start with 1, and what would be the next number? 2, and next 4, 8, 16, etc. So here, if OR was bigger than 1, it would be, for example, divergent. I want it to be convergent.
Fraction.
Not quite.
Less than 0.
Not quite.
Less than 1.
Not this.
Between 1 and 0.
One
Okay, I
over.
give up.
Between -1 and 1 would make it convergent. So, for example, if it was a half, you would have 1, and what would be the next one? A half, quarter,
1 over.
and 8, and it's moving towards, what is it trying to get to? Yeah, what number? It's trying to get to 0, isn't it?
Yeah.
Yeah. What should I use if I want it to be periodic?
Minus.
-1.
-1. Then it will be periodic. And finally, if I want a constant sequence, that is a sequence that doesn't change.
R equals N.
Actually,
UN.
not 0. Almost 0, but why doesn't 0 work?
It doesn't say zero.
But that's what we want. We want a constant sequence.
Oh.
But
This won't be a sequence. It will be just.
zeros are a number.
But it means nothing.
No, 0 means something. Why doesn't 0 work to make a constant sequence?
Because I will be 0.
But that's okay.
It wouldn't be a sequence.
No, hang on. Let's just forget about this. It is a sequence, so get that out of your brain. It is a sequence. Why would it not work to use 0 to make a constant sequence?
U1 is 1.
Yes. Because if you use 0, your sequence would be this. 1, 0, 0, 0. It's nearly constant,
Yeah.
but it's not because of this guy here at the start. Yeah. By the way, if OR was 0, what type of sequence would it be? Divergent, convergent, periodic, or constant?
Convergent.
Yeah. Convergent to what? To 0. Moving to 0. Yeah. Okay. Write this one down, and then I'll give you some questions. Okay. Can I scroll down? Yes?
Yep.
Okay. So you can start these now. 1, A to F. 2, A to C. 3, A to C. 4, A to H. 5, 6, 7. Now the reason there's so many is because they're so easy, and if you like to use your calculator for the questions, you can, to speed things up. So please write these down before I close it.
The 5 A to H.
Yes.
What about 5 to 7?
There's no parts.
A to B or A to N?
To H.
Sorry, this isn't clear, is it?
It's still around.
Yeah, but I changed the mode back. There you go.
What do we take the higher power, or do we multiply them and then take this
I
as?
won't tell you. Because I want you to try for yourself, and I have a funny feeling I'll be doing that one in the tutorial. So I wouldn't want to ruin the surprise for you. Ready? Ready?
The D and the X in rational is the same.
Is it? Well then that's good. You have one less to do. Hi, so what you doing?
I'm doing the video to how to solve the double graph.
No, believe in yourself.
Yeah, I'm just checking.
No, believe in
The way
yourself.
is the same of what I'm thinking.
Okay.
I don't like not knowing. So.
Okay.